Hello, welcome to the last lecture. So if you remember, maybe you're watching this right away and then this is still fresh, but in case it's not, we were looking at this example where we have a normal distribution with a known variance, unknown mean, and we're trying to test the alternate hypothesis that mu is greater than mu zero at level alpha. So I'm insisting on level alpha. Probability of type 1 error has to be set to alpha. Okay, and we want to find, if possible, a UMP test. That means a test that at every value of mu greater than mu zero in the alternative hypothesis set, this test will give the lowest possible type 2 error. We said in the previous lecture that we could do this by using Neyman-Pearson lemma sometimes. So this will play out the method in an example. So we let mu a be greater than mu zero, just be an arbitrary number bigger than mu zero, and we build the test. So remember, the test takes this ratio of the likelihoods and sets it less than k, where k is set based on alpha. So here's my rejection region, in other words. So this is, by NP, the test. It really should say the rejection region of the test that maximizes the power mu a when k is set by alpha. So this maximizes it at mu a. The question is, can I write this in a way that is independent of, not a function of mu a? If I can do that, well then, since mu a was arbitrary, this means this will give me the test that will give me the lowest type 2 error probability for any mu a in the alternate hypothesis set. Okay? And this is where we were. All right. So let's continue then. So it's just a little algebra from here to see this. Currently, if this is the rejection region, it looks like it does depend on mu a to me. But we'll see in a second it doesn't. So let's continue. If we come down here, we say, let's take the log of each side to try to attempt to simplify it. And what do I want to do you think? Well, most of the tests we have test stat less than constant, something like that. Test stat greater than constant. So here I want to isolate a test stat, and the one that'll turn out to be will be the sample mean, will be the test stat. So let's see if we can get it in that form. So I take the log of each side here. Okay, that's clear enough. And I multiplied both sides by -2 after I take the log. That flips the inequality, and I have this summation greater than -2 log k. Okay, now I square these out, and I apply the summation. So I get the yi squareds cancel. Also, what do I get? I get -2, this is what I get, -2 mu 0 ny bar, right? Plus n mu 0 squared. I'm applying the sum. And here I get +2, because there's 2 minus, +2 mu a ny bar, and minus n mu a squared. And still this side didn't change, right? I just carried out that, squared everything out, and combined them. Okay, well remember, I just want to get y bar on this side. So let's continue. I think I'll take a seat. So if we continue, we want to get this on this side. So we have, let's bring the y bar together. So, or what do we have? 2n mu a minus mu 0, mu a minus mu 0 y bar, and this is minus n mu a squared minus mu 0 squared, and still greater than -2 ln k on this side. Right? Okay, so I can add the n to both sides and divide. So, or finally, y bar is greater than, so I add this, right? So I have minus 2 ln k plus n mu a squared minus mu 0 squared all over 2n mu a minus mu 0. Okay, so this is the rejection region for the test. So note. So this is RR. So this is the same test. This is the exact same test as this. Same rejection region. Same rejection region. So this is RR for test. Okay, just to be clear. Okay, well, what to do now? We have to set k based on alpha. So now it's time to setting k based on alpha. Okay, how will we do this? Well, in fact, let's write this whole thing, just call it k star, okay? So this test, I'm going to set this based on alpha. I'm going to set this whole thing based on alpha, right? Because y bar has a normal distribution. So I really want to set this whole thing equal to what? Well, maybe it's not quite clear from that, but let's let that right side be equal to k star. So let's let k star equal that whole right-hand side. So minus 2 ln k plus n mu a squared minus mu 0 squared divided by 2n mu a minus mu 0. Okay? All right, so now we want, okay, so RR is then equal to y greater than k star. Okay, so we want to make, so to set alpha, note that under H0, right, under H0, yi, the outcomes are normal, mu 0, 1. So y bar is normal, mu 0, 1 over n. And alpha equal to the probability type 1 error, is equal to the probability that we reject H0. So we reject under this, right? Probability y bar is greater than k star given mu equals mu 0. Okay, but this, I can standardize this. This is the probability. If I subtract mu 0 from here and divide by 1 over the square root of n, this is the probability z is greater than k star minus mu 0 over 1 over the square root of n, where z is standard normal. Okay. Now, we want this to be alpha, so this implies that k star minus mu 0, I can bring this up here, square root of n, should equal q norm, what? Well, that's the quantile, that should be the 1 minus alpha quantile, right? Because I want the probabilities to the right of this to be alpha. Okay? Well, we're just about there. We found what Q is, and we found what K star is then, and we found what the test is. So K star is equal to, divide by square root of n, add mu 0 plus Q norm 1 minus alpha divided by the square root of n. Okay, our test is, so to summarize, our alpha test is or has rejection region is reject H0. I'm just summarizing it again. Mu equals mu 0 in favor of HA, mu greater than mu 0 if y bar is greater than K star, mu 0 plus Q norm and what do you see? I see mu 0, I see n, I see alpha, but there's no mu a. So since the test is independent, not a function, I mean, of mu a, this is the universally most powerful test for just that's it. This is the UMP test that was asked for. Okay, so you're given an alpha, you know mu 0 from the hypotheses, you have a sample size n, you know y is normal mu 1. This is your K. This is what you want to use on the right. Notice we never went back to here, to this item here. We never went back. We could go back and solve. So, and you would get, but what's the point? You would still have the same number here. It's just you would have mu a here and K here. These combine, one goes up, one goes down to give you the same, ultimate K here, the same K star here. So that's the end. You can find a number there for that, and then you have the test that you need to use. This maximizes the power, so it maximizes the power of mu alpha for every mu alpha at once. Mu a, I should say, at once, while setting the level equal to alpha. Okay, thank you.